understanding the power and impact of tsunamis. Hey everyone, today we're diving into the fascinating and powerful world of tsunamis. These giant waves can cause incredible destruction, but understanding how they form and travel can help us stay safe. Let's break it down in a way that's easy to grasp. Most tsunamis start with massive underwater earthquakes. Imagine the ocean floor as a giant moving puzzle. When a major earthquake occurs beneath the sea, it can suddenly lift or drop sections of the seabed. This abrupt movement displaces the water above, creating waves that travel outward in all directions. But not all earthquakes cause tsunamis. It takes a really strong quake, typically magnitude 7 or higher, and the earthquake must be shallow enough to affect the seabed. If the earthquake is deep or not powerful enough, it won't generate a tsunami. The most destructive tsunamis come from a specific type of earthquake called a subduction zone quake. These happen where one tectonic plate slides beneath another, often creating massive vertical shifts in the seabed. For example, the 2004 earthquake off the coast of Sumatra generated a tsunami with waves that traveled thousands of kilometers across the Indian Ocean. When the seabed moves up and down, it creates a series of waves. The first wave might be smaller, but it's followed by larger, more powerful waves. These waves, called tsunami waves, travel incredibly fast in deep water, up to 720 kilometers per hour, about 450 miles per hour, but they slow down as they approach shallow coastal areas. Think of a tsunami like a giant, long wave. Unlike regular waves, which are short and break quickly, tsunami waves have very long wavelengths and can travel vast distances without losing much energy. As they move into shallower water near the coast, their speed decreases, but their height increases dramatically. Imagine water waves traveling across a calm ocean. They're barely noticeable until they reach the shore and start to pile up. Similarly, a tsunami can travel unnoticed across the deep ocean, but as it hits shallow waters, the wave height can soar to tens of meters, causing immense flooding and damage. When a tsunami reaches the coastline, it doesn't just hit like a typical wave. Instead, it brings a massive amount of water inland. This flood can last for minutes, unlike the brief impact of a regular wave. The water rushes in with incredible force, sweeping away everything in its path: buildings, cars, trees, and even people. Once the tsunami water rushes onto land, several factors influence how destructive it becomes. Narrow bays and estuaries can amplify tsunami waves. Imagine water squeezed through a narrow gap. It rises higher, just like how stretching a hose makes the water spray faster. Resonance. Coastal areas have natural rhythms called resonant frequencies. If the tsunami waves match these frequencies, the water can rise even higher through a process called resonance. Land slope. Gentle slopes allow water to spread out, reducing wave height. Steep coastlines, however, can cause water to pile up quickly, increasing flood heights. Because of these factors, some areas may experience much higher waves than others, even within the same region. While Japan is often in the spotlight for tsunamis, many parts of the world are also at risk. Some of the most dangerous areas include Pacific Ring of Fire. This is a path along the edges of the Pacific Ocean where many earthquakes and volcanic eruptions occur. Countries like Chile, Indonesia, and the west coast of North America are particularly vulnerable. Indian Ocean. The 2004 Sumatra Andaman earthquake is a stark reminder of the destructive potential here. Countries around the Indian Ocean rim, such as Indonesia, India, and Thailand, remain at risk. Atlantic and Caribbean. While less frequent, tsunamis can also occur in these regions due to underwater landslides or seismic activity. Understanding tsunamis helps us prepare and respond effectively. Here are some key safety tips. Heed warnings. If there's an earthquake near the coast, move to higher ground immediately, even if you don't feel a tsunami. Official warnings are crucial. Know the signs. A sudden, unusual rise or fall in sea level or an earthquake are signs to evacuate. Have a plan. Know the safest routes to high ground and establish meeting points for your family. Tsunamis are powerful natural phenomena that result from significant underwater disturbances. By understanding how they form, travel, and impact coastal areas, we can better prepare and protect ourselves from their devastating effects. Remember, while tsunamis can be terrifying, knowledge and preparedness are our best defenses. Stay safe and stay informed.